it reads, a gun on a battleship fires a shell with a muzzle velocity of 750 meters per second. If it takes the shell 0.02 seconds to traverse the full length of the barrel, find A, the acceleration of the shell, B, the length of the barrel, and C, the velocity of the shell halfway down the barrel. Let's take a look at the shell coming out of the barrel. The shell explodes in the barrel, accelerates down the barrel, and emerges. We're told that the shell emerges from the gun with a muzzle velocity of 750 meters per second. We'll let that be the final velocity of the shell. It takes 0.02 seconds to traverse the length of the barrel. Let's let the origin of our coordinate system coincide with the original position of the shell, and let the original velocity of the shell would be equal to 0. We're asked to find the acceleration of the shell, we're asked to find the length of the barrel, and we're also asked to find the velocity of the shell when it is halfway down the barrel. Alright, that's our problem. Why don't you try to solve this problem before watching the solution? Here's a figure of our problem. We have the shell start at t equals 0 with a velocity v0 is equal to 0. The shell then accelerates down the barrel, emerging from the barrel with a final velocity of 750 meters per second in a time t equal to 0.02 seconds. We can allow the origin of our coordinate system to coincide with the original position of the shell, so we write that x0 is equal to 0. The questions in the problem: what is the acceleration? What is the length of the barrel, which translates into what is the distance traveled in the time 0.02 seconds? And lastly, what is the velocity of the shell when it has traveled halfway down the barrel? If the length of the barrel is x, what's the velocity when the distance is x over 2? Looking at the first part of the problem, we can find the acceleration directly from the equation for the definition of acceleration, that it is final velocity 750 meters per second minus the initial velocity, which is 0, divided by the time 0.02 seconds, and that gives you a value of 37,500, and the units on that are, let me put them down here, meters per second per second. 37,500 meters per second is the acceleration. Let's now find the length of the barrel, the distance x. So for part B, let's take a look first of all at our equations. We need to know the distance x. So if we look at the second equation, it does contain the distance x. It contains the final velocity, which we know, the initial velocity, which we know, and the acceleration, which we now know since we just found it. We could also use equation 3. That directly gives us the final displacement x. We know the initial displacement, the initial velocity, the time, and the acceleration. Let's use equation 3. We have not used it yet, and rewrite it up here. For part B, then we write that x is equal to x0. x0 is equal to 0 plus the initial velocity v0 times the time. Well, v0 is 0, so that is 0 also, plus 1/2 the acceleration, 37,500 meters per second multiplied by the time, 0.02 seconds, that quantity squared. If you work that out on your calculator, you should get a value here of 7.5 meters. That then is the length of our barrel, 7.5 meters long. Multiply that approximately by 3 and you get somewhere around 23 feet long. It sounds like a reasonable value for the length of a barrel on a battleship. Let's do part C now. Let's move down and insert it here. We need to know when the value is x over 2. Well, half of that is 3.75 meters, so that's going to be our new value of x. Let me call it x prime. And let's take another look at our equations. We want to know the velocity at that point, a final velocity. This equation contains the final velocity and the distance x, which we're now calling x prime. It contains the acceleration, the initial velocity, the initial displacement. We know all those quantities. So we could use equation 2 in order to find what the velocity was. Let's try that and write that the final velocity squared minus the initial velocity squared, which is 0, is equal to 2 times the acceleration, which is 37,500 meters per second multiplied by the distance, 3.75 meters it now is. This will give me a value of 281,000, rounded to 3 significant figures, meters squared per second squared. The actual velocity would be the square root of that, and if you take the square root of that, you come out with a value 530 meters per second. Notice that it's not half the final velocity of 750 meters per second. All right, so there are our answers. The final velocity 530 meters per second for the velocity halfway down the barrel, the length of the barrel 7.5 meters, and the acceleration itself 37,500 meters per second. All right, let's move on to our next problem. Number 4, let us review some ideas about free fall. The motion called free fall includes the motion of an object that is simply dropped from rest, the motion that is depicted here.